Have you ever struggled with CSS Grid, or the perfect solution you found online just seemed impossible to understand? Well, today that is going to change forever, because in this video you will learn everything about CSS Grid in only 20 minutes. When I first learned about Grid, it seemed very complicated, but now I'm using it all the time to build modern and responsive layouts that look great on any device. No matter if I'm building an online shop or a creative portfolio, it always comes down to CSS Grid. And in this video, I will explain all of it, starting from the absolute basics, all the way to advanced real-world examples. So, after watching this course, you will have the confidence to build any layout you can imagine. It all starts in HTML, because for any type of layout, you will be working with a parent element that contains a few child elements. These make up your grid. We usually call the parent element grid container and all the child elements grid items. That is really all you need in HTML to start working with grid. In CSS, you start by addressing the grid container, where you declare display grid. A grid needs columns and rows. If you don't declare the size or the number of columns and rows, the browser will just do it automatically. In this case, we have just one column and 9 rows. But we can also change that by declaring how many columns and rows our grid should have. For the columns, you use the property grid template columns. Here, every value represents one column. For example, I write 200 pixels 3 times. That way, I end up with 3 columns, each being 200 pixels wide. Pretty simple. To see the grid layout better, we can go to the developer tools in the browser and click on this little icon over here. This is a Firefox feature that will show us the columns and rows with purple lines. That way, it is easier to see what's going on. A lot of times, you don't need to specify the rows of a grid, as this adjusts automatically to the columns you specified. But if you want to, you can use grid template rows to do the same thing for the rows. Let's say 200 pixels 3 times again. Now we have this tic-tac-toe kind of layout. Another cool property you can use is the gap property. This one will create a gap between the columns and rows. So as you can see, the grid template columns property determines not only how many columns the grid should have, but also how big each individual column should be. That means we can easily change the size of one column by modifying these values. For example, 400 pixels. Then this column is a lot bigger than the others. And when you set up any grid layout, even a complicated one, adjusting the number and size of the columns is really all you need to do. But it's not always that easy, because oftentimes when we design a grid layout, these layouts can get very large, and they will only fit properly on a desktop screen. And this is of course not very responsive, which is why it is super important that you sketch out different versions of the same grid for all the different screen sizes. And a cool thing about Grid is that it offers many tools that make everything responsive using only a few lines of code. But before I explain how to do that, let's quickly talk about this amazing tool I'm using right now. Miro is a great innovation workspace where you can brainstorm ideas with your team using a massive collection of templates, which allow you to do basically anything you would need as a developer. That includes designing prototypes, planning processes using all sorts of diagrams that you might know from your computer science studies, and collaborating with your team members. But there's more. What I personally love is how Miro brings all your tools together into a single workspace. That means you can import YouTube videos, Excel or Google Sheets, or even an entire AWS infrastructure. And if you ever work with someone that doesn't know anything about tech, like a client, investor, or business partner, then Miro is definitely the best option to visualize your idea and explain how your software works. That way everyone can understand the process, no matter their background. There's so much more Miro can do, so I highly recommend that you try it out yourself by clicking the first link in the video description. Let's talk about how to improve the responsiveness of your grid. When setting up the columns and rows of your layout, you don't have to use these fixed pixel values. You could also make it a bit more responsive by using a unit called fraction. For example, if I want the grid to fill out the entire width of the website, and each column should have the same size, then we apply 1fr, 1fr, 1fr. Each column is 1 fraction wide. You can see how the grid stretches over the entire screen horizontally. And if I resize the window, the grid will resize automatically. So what do you think will happen if I also use fractions for the rows? So I say 1fr, 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 on grid template rows. Here it is important to know that it will not cover the entire screen, because fractions behave relative to the grid container, not to the window. So only when I assign a height to it, we can see the effect. A cool thing about fractions is that you can also use them relative to one another. So this column over here could also be 2 fractions wide. Then it will be 2 times the size of the others. And you can also mix different units within a grid. For example, let's say our website only has 2 elements, a sidebar and a main content. I will comment out the other elements for now. Then you could create a grid with only 2 columns, using a fixed pixel value for the sidebar and 1 fraction for the main content. So the sidebar will always stay in place and keep its fixed size. But the main content will be flexible and responsive depending on the screen size. So fractions behave very similar to flex grow and flex shrink that you might know from Flexbox. Now let's get back to our previous example and learn more about alignment. Alignment can get a bit confusing if you don't listen closely to what comes next. Because in Grid, we have the alignment of the columns and rows, but we also have the alignment of each item in the cells. To show you this better, I made all columns and rows 300 pixels big. But I also assigned a height and width of 100 pixels to the items. So now the items have a different size than their grid cell. You can see that if you take a look at the purple lines in Firefox. Now to handle the alignment within the cells, you can use justify items and align items. Here you have the values start, end, and center. Justify items handles the horizontal alignment, and align items handles the vertical alignment. If you set both to center, they will be centered perfectly. But then we also have justify content and align content. These are different properties. Let's see what they do. Justify content handles the alignment of the columns. So if I set this to center, it will center the grid horizontally within the grid container. Align content handles the alignment of the rows. If I set this one to center, it will center the grid vertically. But again, don't confuse the grid container with the viewport. If I change the size of the grid container, that will affect these properties too. The grid is only centered within the grid container, not on the entire website. Alright, now you know the basics of creating columns and rows and how to align everything to your liking. But now it's time to explore a concept called implicit grids. So far, we have created a fixed amount of columns and rows, because we knew how many columns and rows we needed. But what if you don't know the number of elements that make up your grid? What if you get your content from a database, like in a search function for example? Then the number of search results can be different every time. How can you make a grid for that? Let's get back to our previous example and learn more about implicit grids. In HTML, we can see how we have 9 boxes. Let's see what happens if I add more elements. Then these 2 boxes will be down here. They are very small and the layout is inconsistent. To fix that, we need to prepare our grid by managing its automatic behavior. What should the grid do automatically? For that, we use the grid auto rows property. Grid auto rows controls the size of every automatically generated row, like this one down here. We only accounted for 3 rows, but we need 4 rows to handle our unexpected elements. Here, I would just apply the same value, 300 pixels again. And now it looks very consistent again. And by the way, this property is actually the reason why I don't use grid template rows that much. We can completely remove it and just use grid auto rows to have the same layout. Now every row is automatic and only the columns are specified. Now in grid layouts, new elements are normally added in a new row. This has to do with the grid auto flow property. Its default value is row. But if you set this property to column, then every new element will be added in a new column. In that case, you would remove the grid template columns and use grid auto columns instead. Here I used 300 pixels again to have automatic columns, each being 300 pixels wide. And of course, if you have too many elements, this will result in overflowing elements. But still, I think you should know about this concept because you can use that if you want to create a website with horizontal scrolling, like in a Netflix slider for example. Now, after understanding the basic grid properties, it is time to learn something more complicated, something that is very unique in CSS Grid. Because technically, everything we have covered so far can be achieved with Flexbox as well. It just works a bit better with these responsive grid settings. But there's also a concept we call Bento Grids. These are grids where elements stretch across multiple columns or rows. They look like Japanese food boxes, which is where the name bento comes from. This is nearly impossible to achieve with Flexbox, but it's very simple in CSS Grid and it can lead to very awesome layouts. Here's how it works. Let's say we wanted to create this layout. Then you can probably see how we need a CSS grid for this. We use grid template columns and grid template rows to create 4 columns and 2 rows. For simplicity, they are all 200 pixels big. But you could also use a more responsive unit like fractions for example. I also use a gap of 1 em to see the individual boxes better. Right now, they are all displayed next to each other, but we can define their exact position in the grid if we name them somehow. Each box needs a name so that we can identify it later. For that, we use the grid area property. You can do this in CSS, but then you would have to address every box individually. So, to save a few lines of code, you could also do this in HTML using the style attribute. This is usually done much faster, and since I don't plan on overwriting these values, we don't have to worry about specificity. The names for the grid area is just box 1, box 2, box 3, and so on. Now that every box has a name for its grid area, we can now decide how big these grid areas should be. In other words, across how many columns or rows they should stretch. And for that we use the property grid template areas. And this is really where all the magic happens. On that property, we can define strings. One string is one row in the grid. Remember, this grid design over here is the goal. So, in the first row, we need box 1, box 2, box 2 again, and box 3. Now we write another string. I'm going to do this in a new line, but we could also write everything in one line of code. In the second row of the grid, we need box 1 again, box 4, box 5, and box 5 again. And in the browser, that should already give us the first grid of the video. So for a beginner, that might be a bit tricky to see, but the grid template areas property contains the information where exactly each box should go. Maybe you'll see it with a bit of video editing. Every string is one row, and the spaces inside the strings separate the columns. And every box has a grid area which serves as their identifier. The cool thing about this property is that we can now change the layout very easily by just changing these strings. For example, I can make box 1 very big by putting it here, and make all the other boxes a bit smaller over here. And this will now give me a completely different layout by just changing one tiny thing. And you can probably see how powerful this can be when thinking about responsive web design. For a smaller display, we just have to come up with a design that is a bit thinner. That means we have to rearrange the grid areas so that all the boxes fit properly. Inside a media query, I changed the values for the grid template columns and grid template rows. We could use a 3x3 grid, for example. Later I will show you how to make this completely automatic. And now, in grid template areas, I create a design that looks somewhat like this. We are just rearranging the 5 grid areas for the 5 boxes so that we have a 3x3 layout. This is now a bit thinner and perfectly suited for tablet devices. And of course, the same thing goes for mobile screens. I can do the same thing again, but this time with only 2 columns and 4 rows. So depending on the screen size, we can always change the grid template areas property to create a grid layout that fits properly. But you might have noticed one annoying thing. We always need to change grid template columns and grid template rows. But I found a way where we don't need to change these properties. There's a solution where you only adjust the grid areas and the columns and rows will follow automatically, because technically that information is already contained in grid template areas. So I will remove grid template columns and grid template rows everywhere, and only at the beginning, up here in my grid container, I will use different properties called grid auto columns and grid auto rows. These properties will now create an implicit grid. That means here we define how big an automatically created column or row should be. They're all 200 pixels. By using these properties, we don't need to specify the columns and rows anymore, since they will be created automatically. I'm not saying that this is the better way. If you really want to be 100% sure, and you want more control over the individual columns and rows, then you will be better off with grid template columns and grid template rows in the media query. But if you prefer a shorter and more automatic way, then do it like this with an implicit grid. Now there are a few things to consider going forward. Right now I'm using a fixed unit. You could also use the unit EM, which is a bit better, but with both of these units, you're limiting the size of the boxes. If that's the goal, then that's of course okay. This could be useful for an image gallery, for example. But the moment you start filling these boxes with content, then things can get messy if you limit the size. This is why we have to make a decision. Do you want to hide overflowing content with overflow hidden and make sure the grid stays in place perfectly, or do you want to have an adaptive grid that resizes itself based on the text content? For that you can use the value auto or 1 fraction for the automatic rows. But what is the difference? The value auto is dependent on the text content. Here, if there's no content or padding, then there's no row. If there's more text content, the height of the row will adjust automatically. But I think this will make it really difficult to balance the layout, because now the content has to be balanced perfectly to make this grid look good. The other option for an adaptive grid is the value 1 fraction. If you use 1 fraction, then all the rows, they're all the same size, and for me that works a lot better. That means if I start filling the first row with a bit of content and it grows bigger, then the other rows will also grow accordingly. But just a general recommendation here. Don't fill these Bento grids with too much text. I believe these grids work way better with images and cool graphs, because most of the time the goal is to make a product look awesome and not to present a big amount of information. Now before we move on to my favorite way of using grid layouts, where we create a responsive layout for an online shop, let's talk about a topic that shows how you can use grid in a completely unexpected but powerful way. Because so far we've only used grid to create responsive layouts. But grid is actually more powerful than that, because we can use the same properties to solve completely different problems too. For example, if you want to stack certain elements, like when you want to place text on top of an image, or put a video behind a website section, then you would use a concept called grid stacking. It is entirely possible with the grid properties you already know. You just have to get a bit creative. Here's how it works. When you have a grid layout defined, you can target the child elements and use the properties grid row and grid column. These properties control how many columns or rows an element should span. For example, if I set grid column to 1/3, the element stretches across 2 columns, because grid lines are counted 1, 2, 3. Now, why am I telling you this? Because we can use this exact concept to make child elements overlap. Let's assign the same cell in the middle to our second child by making it stretch from line 2 to line 4. By default, that will push it into another row. So we also have to set the same grid row, 1/2, and do that for both child elements. Now you can see how they overlap. It is even clearer if I lower the opacity on one of them. So when 2 elements share the same grid cell, we essentially get the same behavior we want from absolute positioning, overlapping elements that are positioned relative to their parent. A common example for this would be to place text on top of an image. With absolute positioning, you would have a wrapper with position relative and a text container with position absolute, and then use the top, left, bottom, right values to position it exactly where you want it. This works totally fine, but here's the same thing with grid stacking. Remove all of this and instead set the wrapper to display grid. This will automatically create a 1x1 grid without defining rows or columns. We don't need them. Now on the text container, set both grid column and grid row to start at line 1 and end at line 2, meaning it covers the entire grid, since this is only one cell. On the image, we do exactly the same. Grid row and grid column 1, 2, and that will make them overlap perfectly, just like with absolute positioning, but with the advantage that we now have access to all those fancy grid properties. For example, we can use place items to align the elements at the start, at the end, or even in the center, without having to calculate top 50% and translating it back as you would have to do it in position absolute. Right now, we're stacking the CSS grid using grid row and grid column, but the cool thing is there's actually a shorter and more readable way which I prefer. Let's use that in the next example. Imagine you want to play a large video in the background of your header section. Here's my video element, which has all the important attributes we need to make it play in the background. With absolute positioning, you would often have to set either the video or the text content to position absolute. That will work fine. But if the content size changes dynamically, you could run into some ugly overflow issues. But with grid stacking, you don't have to worry about that. Let's remove the absolute positioning and set the header to display grid. This time I will use grid template areas. I simply define one area and call it stack. Now on both the video and the text container, I assign that grid area, stack. It is very readable and you can see how both elements stack in the browser. Now to control which element is on top, I just use the z-index property. The higher the value, the closer the element is to the viewer. And again, we can center everything with place items center. Very intuitive. Alright, so far you should already have a good understanding about the properties we have in CSS Grid. But the most important grid concept is still missing. The one concept that is used in most real-life applications, a concept I call grid wrapping, where the grid is able to adjust the amount of columns that fit on the screen at once. If there is not enough space, it will simply eliminate a column and put the items into the remaining columns. It is doing all of this automatically, responsively, without any media queries. And to learn about this concept more practically, let's implement it into this basic online shop layout. We want to create a wrapping grid that shows these products in a responsive way. Depending on the screen size, the grid will automatically add or remove columns, so that the website looks great on any device. Let's take a look at what we have got so far. We have a basic website with a products list. These products are simple div containers with an image, a name, and a price. That's it. They have very basic styles. Display flex and flex direction column to have a vertical layout within the containers. The image has a height auto-applied so that the height can resize properly if we change the size of the image using grid, which we will do. So let's take a look at the grid layout. In the product list, we have of course display grid. The columns are pretty basic, just 3 columns, each 300 pixels. In the browser, that means this grid is not responsive. If I resize the window, these columns will overflow. To calculate how many columns can fit automatically, we have to use a function called repeat. This function is pretty powerful. It takes 2 arguments. The first one determines how many times you want to repeat, and the second one, what value you want to repeat. For example, I can say repeat 3 times 300 pixels. Then that would be exactly the same as before, just using the repeat function. If I say repeat 4 times, it will create 4 columns of 300 pixels. So far, pretty simple. But we don't have to use a fixed number value here. We can also use the keyword autofit. Then it will check automatically how many times we can repeat the value 300 pixels, depending on how much space there is. So if I resize the browser window, you can already see how it will create and delete columns depending on the screen size. Pretty simple and yet very responsive. But we can also make it even more responsive by introducing fractions into this layout. You see, sometimes we have a screen size where there's not enough space for another column. But we do have some white space that we could fill out. So at this screen size, we could make the remaining columns slightly bigger, until we have enough space to create another column. For that, we have to adjust the second parameter. Here, we provide a size range instead, using the minmax function. The minimum value should be 300 pixels, but the max value should be 1 fraction. So essentially, we're telling the browser, try to auto-fit as many columns next to each other as possible. And each column should be between 300 pixels and 1 fraction wide. That way, there is no white space, and we end up with a responsively wrapping grid, where the columns can resize if needed. Pretty awesome. And with that, you have just completed an entire deep dive into CSS Grid. But this is only the beginning. If you're ready to move beyond layout and actually start building interactive websites, then it's time to learn JavaScript. I've created a full 8 hours JavaScript course, beginner-friendly but fast-paced, so you can see results quickly by building hands-on projects. You will learn everything about programming in JavaScript, which will open the doors to all those libraries and frameworks that you plan to learn. So if you want to learn React in the future, or Angular, or Vue.js, then you will have to learn JavaScript first. You can get my course on Udemy using the link in the video description. My name is Fabian, and this was Coding to Go. I will see you in the next video.